when it comes to Newman projections, what I want you to do is think of it not as much as like a chiral carbon in the front and then a chiral carbon in the back, because there is like a carbon chain connector between the two of those. So really, it looks more like this, like that. That's more of what this looks like. And so you're gonna be looking at it almost, so say this is like the carbon connector right here. Well, then we're gonna look at it from this side right here, in which this front carbon is gonna be now on our left over here. And then, so this back carbon is gonna be over here. This molecule and this bromine, so this methyl and this bromine, anything on the right side, whether it's the front or the back carbon, is gonna be your wedge. Anything that's on the left side is gonna be your dash. And then anything else, like these two, the hydrogen here and this bromine, are just gonna be your lines, like what you're kind of used to. So you're gonna go ahead and attach so this right here, I kind of have it looking like it's a carbon, but this is gonna be like your bromine and your hydrogen is what that little line is gonna be that I just like kind of moved here. I'll make this one look less like a carbon and more like, so this right here on the right, which is going to be our wedge, right, is going to be this methyl group. Then we're going to have our little hydrogen that's on the left over here be what's behind us, you know, like what's going away from us. And then this is going to be this bromine right here, because it's just like up and down, right? So what's to the right is going to be your wedge. What's to the left is going to be your dash. What's in the middle will just be a straight, you know, like not a wedge or a dash. Then we're going to look at this side, which is going to be the back carbon, right? So the right side's going to be the back carbon. And so on the right here, our wedge is going to be that bromine. Our dash is going to be the methyl group right here, see? And then what's just on the line is going to be this hydrogen here. Now that we have like this sawhorse structure going on, now we're going to go ahead and do our priority. So obviously bromine is going to be number 1. This methyl group is in the back and this is not, so we know that we're going to have an inversion. Then the next priority is going to be this carbon over here, right? Because this is in the back over here, and it's not going to be this. So the fourth thing that this is connected to is this carbon over here. And since this carbon's connected to this, it's obviously going to be second. Then we're going to have this in the back, the methyl group be third. Then we're going to have this hydrogen be fourth. Well, since the hydrogen, this is kind of going like, you know, counterclockwise, which would be S, but since this hydrogen here is not in the back, it's going to be R, okay? Then, so let me erase all this so we can see this a little better. And keep that R there. So that right side is going to be R. And then what you do for this left side is this bromine here is going to be 1, just like it was on the other side. Then since this carbon over here, even though this is on a wedge, since this carbon over here is connected to this bromine, while this carbon over here, the next best thing that it's connected to is this hydrogen, we're going to go to the bromine carbon, because this is more heavily weighted. So this is going to be 2. Well, this is going to be 3. And then this hydrogen's in the back, which is what we like. So you want, you won't have any inversions, right? So then you go clockwise, which is also R. So this is an R structure. So what I suggest is you just, these kinds of Newman projections are really hard to kind of be able to make sense of in your mind. So I know that these like sawhorse like line structures are a bit easier for people to understand. So you always want to convert it into whatever is going to be easiest for you to be able to imagine in your mind, and be able to do circles with these, because I know that Dr. Smith was telling y'all don't be doing circles. So this is probably the best way that I would say to do that. And we can go down here. So I know that he's going to have you guys do converting like the Newman structures into the line structures, which is, these are sawhorses, so they're a little bit different, but for the most part, they're pretty similar. But what you can do for these is you want to determine what each of the, what the stereochemistry of each of these like answer choices is going to be. So then whenever you make your sawhorse like line structure for this one, you're going to be able to see, oh, okay, this is going to be, this is going to be this. And so we'll just match up the stereochemistry with the Newman projection to your structure over here, because when you look at this right here, you've got this going this way, which is going to be clockwise, which is R. You've got this going this way, which is still clockwise and going to be R. So then you've got this way and then this way, but it's both going to be S, because it's in the back. This one's going to be R. This one looks like it's going to be R, but it's going to be S because of the inversion of like the this fluorine being in the back. Not necessarily the inversion, because I shouldn't have used that word for that. But anyways, so this one, it looks like R, but it's going to be S. And this one looks like R, and it is going to be R. So now we just need to convert this into the stereochemistry that it is, right? So go back to our little chart that hopefully you'll have time to like look at and be able to practice and memorize by tomorrow. But so we look at how it's the staggered number 1, right? So it's going to look like this. So then on your right side for this front, oops, that's not the one I wanted to do. For this front carbon, this is the one we're looking at. The one that's on the right is going to be our wedge. So we're looking at the left one over here, right? Because this is the front carbon. So, the right one is going to be, so think of like, so I know this looks like there's 4 carbons here, like 1, 2, 3, and 4, but really it's just 2 carbons. It's your front carbon, so like front, and then your back one. So then you can use these 2 little methyl looking groups, even though they're not methyl groups. You can use those to be like, okay, well that's going to be like what's on the top and the bottom right here, right? And so to put the other groups like opposite of it, if that makes sense. So anyway, for this right side, we are going to do on the right, for the left side, we're going to have the fluorine be on the wedge, and we're going to have this hydrogen on the dash. Then we're going to have this here, not this one that I have circled, but this one go right here. And I'm just writing it backwards so that the carbon's the one connecting to the other stuff, because hydrogen can't, you know, connect to both the carbon and to this carbon as well, if that makes sense. Then we're going to look at the back carbon, which this is on the right as well, so that's going to be our wedge. And then this is going to be our dash right here. Sorry, I was looking at the other thing. So what's on our wedge? The fluorine is going to be on our wedge. I'm trying to see what it's... Anyways, okay. That fluorine's going to be on our wedge, and then this is going to be a hydrogen, right? Because this is on the left, and then this methyl group is going to be on top. Just like it is on the other side, but... Okay. So that's good. We have both of our hydrogens, you know, in the back, which is always what you want. So we're going to start with this fluorine right here. You can really start with either of them, but I'm going to start with this right one just because. And so this is first priority, right? Then this carbon right here is going to be second priority because it's attached to a fluorine, while this carbon over here is just attached to a hydrogen. And then this is going to be third in priority, while this is fourth. So that's a pretty obvious R. And then we're going to go over to, let me delete this. I'm going to go over to this fluorine. So that's going to be 1. This carbon right here that's connected to this fluorine that we just handled is going to be number 2. Well, this is going to be 3, and this is going to be 4. So it's also going to be an R. So this Newman projection is an RR structure. So then we just look at what we've already done, right? So we know it can't be B because that's SS. We know it can't be C because that's RS. This is SR, so it has to be A. So I hope that's helpful. Let me know if it is. And if you have any more questions, just let me know.